So in today's video, we're going to do the long-awaited upgrade to my network where I move to a full UniFi environment. So the equipment we'll be installing here is the UniFi CloudKey Gen2 Plus, which will be the new management controller, as well as being able to act as a DVR for cameras I'll be adding in the future. That'll be the next video. We've then got the new NanoHD access point I'll be upgrading to. So this will be a really nice high-performance access point that should be much better than my current one. Then finally, I'm replacing my router with the UniFi Security Gateway Pro. And this should be an absolutely excellent device. And what I'm really looking forward to is having a full UniFi environment, because it'll mean I can manage everything from a single place, and it should just be so much easier and quicker to work with. So what we'll do first of all is we'll take a quick look at my current environment, see what I've got set up there. Then I'll be disconnecting absolutely everything, resetting it completely back to factory defaults, and we'll set up a completely fresh environment using this kit, as well as some of the kit I've already got. So what we'll do first of all is we're going to take a look at my current network. So this will probably serve as a bit of a recap for people who have seen my videos before. But in my hall cupboard we have this wall cabinet. So we can open that up, and you see along the top here we've got a patch panel. This is connected to all the network ports throughout the flat, so there's various network ports on walls throughout the place, 21 in total currently, and they all go to this patch panel. Below the patch panel we've got a switch, which is a UniFi 24 port switch. This isn't a PoE model, but it's a pretty decent UniFi switch. Below that we've then got the 3U blanking plate, which has some stuff mounted to it. So on the left we've got a PoE injector for my access point. This is a really old Ubiquiti PoE injector. You can see it's even got their old logo on it, and that just powers my access point. On the right here we've then got my OpenReach modem, which is the modem that my ISP provided me with quite a while ago. Since then they've provided me with their own router, their own built-in all-in-one router thing that's absolutely rubbish. So I'm continuing to use this OpenReach modem because it is so much better. This provides me with my internet connection, which is an 80 down 20 up fibre to cabinet connection from PlusNet. It's actually fine for my needs, but when my contract expires I might look into moving something a bit faster like their GFast system, which I think's 330 down 50 up, but for now this works absolutely fine. Then below that we've got a simple 6 connector PDU, which isn't anything fancy, it's not managed, it's nothing like that. It's just a cheap generic thing with 6 standard UK wall sockets on it to plug all the devices into. And that's rack mounted here. There's then that black cable that comes out the bottom there, and that goes round the room, tacked to the wall and plugs into a socket. And then all the cables from the patch panel go up through the ceiling. So next in the hall we've got my access point, which is an original generation UniFi AP Pro. So this isn't wireless AC or anything like that, it's just dual band wireless in. And if we remove that from the ceiling, because you can just twist it to release it, and then it drops down like that. You can see there's a single cable going to the back of that that's providing power and data to it. This plate behind it here is mounted onto a standard 1-gang UK back box, and I think the new access point should mount natively onto that, which should be a lot neater. And up inside that back box there's just a keystone jack on a cable, and then a patch lead going from that into the access point, because I personally prefer having all my structured cabling terminated in RJ45 keystone jacks rather than terminating into actual RJ45 connectors themselves. So yeah, that's the old access point, and that'll be getting upgraded to the NanoHD. Finally in the living room I've got this other small rack, which has various equipment in it. It's got an AV receiver up the top that's just off camera, a home theatre PC here, and then we've got the networking stuff. So we've got my router, which is currently a fairly cheap 1U server from AliExpress. I did a video about this a while ago, and it's actually worked really well, and this thing's running VyOS as my router's operating system. But it's getting a bit of a pain to manage it completely separately, so having the UniFi environment definitely appeals to me. So that'll be being replaced, and then below that we've got another 24 port UniFi switch, exactly the same as the one in the hall cupboard. This will be getting kept. This is connected up with a 4-port link aggregation to the switch in the hall cupboard, so they're both linked together. Then below that we've got my server, which is an old Fujitsu Primergy TX1310M1, which is a fairly decent Xeon E3 based server running FreeBSD. It works pretty well. I might upgrade it in the future. I really do want a rack mount model, but it works okay for now. And then finally below that we've got an APC rack mount PDU. So this is a proper rack mount network managed PDU, and that powers everything in the rack. So now the next thing I need to do is disconnect absolutely everything. I don't want to keep the current config on any of the networking equipment because it's a bit rubbish, and I just want to set everything up completely from scratch. So what I'm going to be doing is powering all the stuff down. I'll leave the server and stuff on, but I'll power down all the network equipment, the routers, the switch, all that sort of stuff. I'll get powered down, reset and taken out the rack. So what I'll do is I'll go away and do that, and we'll come back and take a look at all the hardware we're putting back in. So there we go, say hello to my new network. Admittedly a very temporary network until I get the new one up and running, but yep, this is what I'm going to be stuck with for a wee while. this fine specimen of a high quality router from PlusNet. Yeah, I had to try and get this thing to connect to my DSL, and even that was an absolute nightmare. So the next step is to get all the old equipment pulled out, then we'll take a look at all the equipment we're putting back in. Okay, so I'm just quickly jumping back in here. I've got a wee bit further, I've just disconnected everything up here and removed all the cables. But I've literally been using this PlusNet router for all of 15 minutes at this point, and it's already packed in. It's already stopped connecting to the internet, and it's flashing a B and gone orange. Like, oh, and now it's back on. So literally, how rubbish, like I always forget when I'm using all this nice new enterprise kit, how rubbish the consumer grade stuff is and how people just suffer with all this rubbish. Like literally, it just died there, picked out the camera, and now it started working again. What an absolute piece of junk this thing is, like really. Oh well, hopefully don't need to use it for long. So now here we have all the kit that'll be going in. So on the left here we've got my CloudKey Gen2 Plus and NanoHD access point. Then below that we've got the UniFi Security Gateway Pro. And at the bottom we've got my two 24-port switches that I was using previously. These will be going back into service, however for this deployment I've done full factory resets on them. So everything here will be being set up completely from scratch. Next up on the right we've got my OpenReach modem that I've shown before. So this will be going back into service mounted on a rack shelf. And then finally we've got this interesting device here that I showed in my previous video, which is a rack mount PoE injector. So this is an 8-port PoE injector. Each vertically stacked pair of ports acts as one injector. And it's designed to be quite high quality, high power, and does proper auto negotiation. So if you connect a non-PoE device to it, it won't power it. So that's quite good. So this will be going into the hall cupboard rack as well. So yeah, that's all the equipment there. So what I'll now do is I'll go away and show where I'm going to install some of it, go away and install it all off camera, and then come back for the setup. I've also just realised that while I've got videos of most of the products here, I've not actually got anything about these UniFi switches, because I bought them about a year ago when I was doing the flat move stuff, and I was just so busy with all the moving and the other videos that I never got around to doing a review of them. So just do a very quick tour, nothing that fancy, obviously we'll see the full setup later. But they're nice switches, they've got 24 ports on the front, so you've got 24 RJ45 Ethernet ports and a pair of SFP ports, so you can connect fibre modules into that, DAC cables, or even just SFP to RJ45 copper modules. And the cool thing with this device is that these are additional ports, they're not dual personality. So on some switches you'll have 24 ports, and the last two are shared with the SFP. On this, it actually has two separate SFP ports. So you've actually effectively got 26 ports here on this switch, which is really nice to have. And just to sort of dispel some misinformation people keep putting across on YouTube, these are SFP, they're not SFP+, so they are just gigabit ports. So you've got no real speed benefit using these. You've got other benefits, obviously, with fibre giving you, electrical isolation and stuff like that, but they are just gigabit SFP, so it's not faster using these. There's just different use cases that might require them. Now in the hall cupboard here, I've got 21 network runs throughout the flat, but then I'll also be using a port for the CloudKey and router, which will only leave me like one port left, and I've got to actually use two because I need to connect the second camera up. So what I'll do in the CCTV video more than likely, I'll probably get some sort of SFP modules for this to free up some additional ports. So we'll see that later. Then around the back of the switch, let's take a quick look here. We've got an RJ45 console port. This is just a serial port. You don't really need this much. In fact, I've never used it. But you can use that potentially if you need to rescue the switch or try and help it see the controller, things like that. There's an RJ45 console port there. You've got a little tiny fan. Don't know how big that is. Maybe it looks like 30mm, maybe 20mm, 25mm, something like that. It is quite loud when it runs, but to be honest, apart from when you switch the switch on for the first time, the fan spends its whole time off, so I can't really see this being a problem, unless you're running it in a really hot environment. Finally over here you've got the power inputs, so you've got a standard IEC mains connector, as well as this 25V DC connector. Now this is actually redundant power, so you can connect your mains power supply to the mains there, but you can also connect an external 25V supply, so if the mains power supply or mains supply itself fails, it'll fail over to this. So that's a really nice technique of doing it, because you get a lot of switches with redundant power supplies, but then you've got two full mains power supplies in it, which obviously puts the cost up quite a lot. So it's quite clever what they've done here, that you can use your mains supply normally, but if you want redundant power you can get a separate 25V supply and hook it up into your switch. And potentially if you had a lot of switches, you could probably get quite a high powered 25V supply and run it into multiple switches. So that's quite a nice design for redundant power without increasing the cost too much. So now here I am in the hall cupboard where we've got the main rack installed. So this is where I'll be putting most of that kit. So what I'll be doing, what I'll be installing in here will be the switch, PoE injector, USG and CloudKey. So all that will be going in here. Now you can see this rack here is officially rated as a 6U rack. It's got 6 U's in the middle numbered, and that's what it was sold as. However, interestingly, if you look down the bottom there and up the top, there's additional sort of spaces for devices that just aren't labelled. So it's almost actually an 8U rack. Now the top and bottom ones are a bit inconvenient to use because this overhang gets in the way of screwdrivers and stuff. But there is additional space there for me to use. Now for the kit I'll be installing right now, 4Us would be enough because I'll have the 3 rack mount devices and then a shelf holding the modem and CloudKey. However, if I get the CloudKey rack mount kit, that'll then take up an extra U, so I won't have enough. So what I'll do for now, just to give myself a bit of extra headroom, is I'm going to move this patch panel up to the very top. Below that I'll install the PoE injector, below that I'll install the switch, the USG, and then a shelf to hold the CloudKey and the modem. So yeah, I'll need to go away and do all that off camera, but that's what's going in here. So now let's very quickly go over how I'm going to install this access point. So if we look at the ceiling in the hall here, we can see where we had the access point before. And what that is there is a standard UK dry lining box. So these are the same sort of back boxes that you'd use behind a light switch or a socket, and this is a standard single gang one that's 47mm deep. And inside that, we've got a bit Cat 6 with a keystone jack on the end. This is something I mentioned before, and it's just personally I much prefer terminating structured cabling to jacks rather than the actual RJ45 connector. I find it easier to terminate. I feel this is more durable because it's not got a stupid little clip to break off. And also this is solid core cable because it's punched into a patch panel at the other end. And then generally if I'm crimping RJ45 on, I much prefer using a stranded cable rather than solid core. So this is just how I've done it. So what I would then do here is I'd then connect a patch cable onto this and then go into the access point, which is what I had before. However, with this new access point, it comes with this mounting plate. And I don't think this is intentional. I don't think this is an official supported mounting mechanism. So don't get too upset like if it doesn't work for your particular model of access point. This just happens to work with my NanoHD. But this is the mounting plate it comes with, which perfectly lines up with the screw threads on the back box. So my plan here is to screw this up onto that, feed the cable out round the corner of this back plate, and then mount the access point on it. So the whole thing will be hanging off of this back box with the cable connections all held neatly inside it. So obviously, yep, this is probably not an official mechanism to mount this, and obviously it'll probably only work in the UK because of this size of back box. US ones are probably different. But yeah, it might be quite fun to mount it this way. So I'll go and give this a go. Okay, so I've mounted the back plate and I've installed the cable. So the cable connects up in there and just pops out this corner like that with quite a short length available. So now we should be able to connect the access point to this. It's definitely a bit of a tight fit, but it does seem to fit. So with the access point there with the connection inside it. So all we do is we plug that cable into the AP, like that. Push up the ceiling, there's a nice little guide on the top to show where you're meant to line up to on the back plate. Push up there, turn it around, and that's it clipped on. So now that's the AP mounted up there, looks really neat. And all you need to do to release it is there's a little hole inside to put a screwdriver in, put it in, flick it up, turn the access point round, and it'll pop back down again. So that's quite a nice mounting mechanism. Again, this probably isn't official, you're probably just meant to normally put just a couple of screws through it, and like into the plasterboard or something. But yeah, it does seem to mount to a UK back box fairly well. Okay, so to just give a quick progress update, I've now got all the equipment installed in the rack, so you can open that up there and take a look. Just showing this now before I ruin it by adding all the cables, because it looks really neat right now, but as soon as I add the cables it's not going to look as nice. But you see we've got the patch panel up at the very top, PoE injector, switch, USG, and then this shelf holding the CloudKey and the modem, and then the PDU where it was before. So yeah, just now need to get all the cables in place and start configuring it. So that's everything now wrapped and cabled in. And the cables definitely do spoil the look of it a bit, but they're fine for now. I might try and get neater ones. There's those slim run ones, so I'm not sure how good they are, but they might be a bit neater. So I might do that later because these cables are massive and chunky and stiff. But it looks okay for now. So let's power it all up. So all devices in here are fully factory reset. So what we'll do is we'll switch it all on, we'll see what sort of state it comes up in, and try and configure it from scratch. So we'll just switch mains power on here and we'll see it start up. There we hear that USG firing up. Switch is also making a noise because the fan hasn't kicked off, like shut itself down yet. I'm just looking over to the access point and it's now blinking white, so the access point's starting up as well. So that's everything now powered up nicely in there. You see it's all running. And both the UniFi devices are sitting with white LEDs on them, which indicates that they're not provisioned, but they're ready to be provisioned. And now here you can see that both the access point and living room switch both have white LEDs on, indicating that they're ready to be provisioned. We can also see down on the CloudKey here, its screen is ticking along showing an IP address, and then it switches over and shows just information about getting their app. But the CloudKey does have an IP address. I also plugged the laptop into the network, and it also got an IP address over DHCP. So what seems to have happened now is the security gateway is booted up, and is acting as a basic DHCP server, and the switches are acting as basic unmanaged switches. So everything's connected together and getting IP addresses and stuff. So we should now just be able to connect a laptop to it, load up the controller, and start configuring. Okay, so let's get all this set up. So as you saw before, I've got everything powered up and everything sitting with the white LEDs on, indicating that they're ready to be provisioned. The USG then appears to be giving out IP addresses over DHCP, so my laptop's got one which is now connected with a cable to one of the switches, as does the CloudKey. And what appears to happen is that in the basic factory config, the USG acts as a DHCP server and potentially a basic router, and all the switches act as unmanaged switches, which is really good, so you can plug stuff into the completely unconfigured equipment and get enough of a network going that you can then start to configure stuff. So now we're all connected up, we've got an IP address, let's try and go to the IP of the CloudKey, which is displayed on the front, which is also really useful. And there we go, we've got a certificate warning, that's completely understandable. And now as you can see, we've got the three options. So we've now got the option for the UniFi SDN, which is the management for the UniFi equipment, UniFi Protect, which is the NVR software for cameras, and the CloudKey settings. So I'll quickly pop into CloudKey settings just to see what we've got in here. There we go, so the basic thing is just UBNT and UBNT for the username and password. So this is really good, it forces you to set a better password on it, which is nice. So you can't leave it with the default password, so that's quite good. Cool, so I'm now logged into this and changed the password. And we see what we get here, so we get access to the UniFi software there, and the UniFi Protect here with the version numbers. These might need updated later. We've then got the CloudKey information here, so we can see the general firmware versions, MAC address, IP addresses, that sort of stuff. We can go over to system stats, we can see the temperature, memory usage, CPU load, and the storage usage. And back on the main screen we can do basic configuration, such as setting regions, hostname, software updates, things like that. And there's a couple of quite nice things in here. So first of all, there's an option here that lets you disable the reset button. So that's quite smart, so you can't accidentally update it, so that's quite, accidentally reset it, so that's quite good. Next up here, you've got an option for fallback IP address. Now this is really nice. So if you've got this device operating on DHCP, and then the DHCP server fails, it'll actually fall over to a different IP address that's defined here, which would allow you to get back into the controller and reconfigure it to fix the network. That's much better than the other alternative where the thing doesn't get an IP address and just sits with no network connection, because then how do you get back in to fix it? So they've clearly thought about that, which is nice. So yeah, that's the basic CloudKey management. Now let's get the UniFi environment set up. So we're going to go down here to the UniFi SDN option, hit launch, and that's going to pull up the UniFi controller. So we're down the UniFi wizard for the first time. So you can pick the country. This is quite important because this will define things about the wireless radios and what they can operate on. Time zone, yeah, UTC is probably fine. I could pick time zone 1, that'll do. Auto backup will leave on, so that'll take up automatic backups of the configuration to the hard drive, so you've got a rolling backup of your configuration, which is nice. Hit next, and as you can see, it's found all the devices. So it's found my 2 switches, the access point, and the security gateway, and not as well as listing the IP addresses for them all. So what we can now do is we can just tick all those and say, yep, we want to configure all those devices, so that'll should provision them all. Hit next. Now it's asking me to define IP addresses, SSIDs and stuff for the Wi-Fi, so we'll do that now. And then put a password up key in here. Then we hit next here. Now it's asking me to set up some admin credentials, so I'll go and do that now off camera, and I'll come back when I've done this. Okay, so now we're done, so we've got all the settings in here. So we're just going to hit finish now. And now it's asking me if I want to set up a Ubiquiti account. I'm not going to do that, and that's just because I just don't really need it. So what you can do with a Ubiquiti account is you can sign up for their cloud management, log in here, and this will let you manage your controller from their website, so you can manage it from anywhere with an internet connection, rather than needing access to your network. I don't really need this, and I tend to prefer having management completely isolated to myself, so I'm going to skip this. Now, I'm going to not skip this right now. I'm just going to wait a little second, because I've just noticed that all the switch ports have turned off, because I think the switch is rebooting while it's provisioning. So I'm just going to wait for that to finish rebooting, and then I'll hit continue. Okay, so the switch seems to be back up now, so I'll try and connect again. So hit skip. And yep, that's continued. So yeah, what happened there is, right as I was about to hit skip there, I noticed the switch in the corner of the room rebooted itself. So obviously when you hit finish for the first time, that must cause all the equipment to reprovision, and then that can cause an initial reboot. It would have been quite nice if hitting finish made a thing pop up saying please wait rebooting devices, so I didn't have, end up hitting skip there and probably get errors because I've not got a network connection. But I just waited until all the equipment rebooted and it seems to work. So now we're back at the login screen for the UniFi controller. So we can log in here. And now if we log in, we should get the whole UniFi environment up. Might be a bit slow the first time because it's the first time it's all been used and things won't be cached and things like that, but we're logging in now. Okay, so I'm now in the UniFi controller, and if we go over to devices on the left, we can see it has found all the 3 devices I have, so that's definitely working. And yeah, so we've got the basic setup here. I don't appear to have an internet connection yet, that appears to be down, so I'll need to try and work out the settings. At the very least, I'll need to set up the PPPoE settings to get my modem connected up. So I'll go away and do that and try and get a basic setup working, and then come back when it's done and I'll talk about my experiences of setting it up. Okay, and I now have a working internet connection, so if we go to like Google, it works. So all I had to do to set this up, and this will really apply to people with OpenReach modems, different modems will vary, but all I had to do was go down to the little gears down in the corner here, hit settings, go to networks, there's already a WAN network in here, go into here, and just change from DHCP to PPPoE, and enter my credentials for my PPPoE connection. So that was pretty easy. So that's definitely pretty simple. And down here there's a few other options. You can set up DNS servers, smart queues, which is some sort of QoS I think. You can do IPv6 if you've got an IPv6 capable connection. And also interesting, there's an option to use a VLAN ID on your WAN interface. This is quite good because when I was previously working with a different internet connection using a non-OpenReach modem, you had to set a VLAN ID on the interface for the WAN connection. Now I think that the OpenReach modem just does that automatically, so you don't need to do it with that. But if you're using a different modem with an OpenReach connection that you might need to set a VLAN on, it's really good having that option here in the web interface so you can set that up without having to do any manual overriding config stuff. So that's definitely a basic connection working right now. And because we've got an internet connection, we can go over back into the CloudKey settings themselves. 8. Go over to the Manage CloudKey, log in here, and go to Configure. And we'll see there's updates available, so it's already showing that there's updates available for both the CloudKey itself and the UniFi SDN software, which will take me from 5.8 of the UniFi software to 5.9, which if I remember correctly is quite a big jump in terms of the UI, so that'll be a nice big improvement. And also the CloudKey will update itself as well. So what I'll do now is I'll do all these updates, I'll then go away and configure the rest of my network because it's going to take ages and it's going to be quite specific to me, so there's no point showing it on camera, and then I'll come back with my experience. Okay, so everything's now set up, and I'm actually really impressed with how well it works. So I'm not going to dwell too much and show absolutely everything about this because there's so much to go through, but we'll go through a quick run through of the controller, talk about my experiences, talk about a few issues I've had, and then we'll go into some performance tests. So here we are on the controller, and here's the main screen, and I've just updated to the latest version, which now lets you switch between a light theme and a dark theme, which is actually really nice because I really like dark themes. This is actually quite a nice feature improvement. So this is the main dashboard. Apparently everything is great, and 100% shows that my average Wi-Fi device has a score of 100%. It's a sort of arbitrary Wi-Fi score they've made up. But over here you can see the load on the WAN interface and all the various sort of points throughout the network. So on the left here you've got the internet capacity, which is the utilization of my WAN network. What it does is it does a speed test, so it works out the maximum capacity of my internet connection. So this is a percentage of that maximum capacity, which is quite cool. And you can set it to run that speed test on regular intervals to keep that speed up to date. This is then the CPU load of the USG, number of switches, the access points I've got, the Wi-Fi clients I've got, and then guest Wi-Fi clients. It's not too useful, but it's an interesting breakdown. Down here you've then got some dashboards. Now this is quite cool. So over here we're seeing the overall utilization of my internet connection, the device distribution between wireless and wired and all that sort of stuff, summary of all the switches to show what switches I've got, how many clients there are, port utilization, categories of traffic going through the network, Wi-Fi clients, all that sort of stuff. But this is fully customizable. So you can hit edit widgets and completely create your own dashboard here. Again, it's a bit of eye candy more than anything, but you can use it to build your own dashboard of your network, which is kind of cool. Going on to the more serious stuff, we can go down the left and go to statistics. So we pull this up here. It shows first of all quite a high level page of just different devices, what the most active AP is, things like that, the number of clients connected throughout the day, stuff like that. Nothing too exciting, but you can break this down into much more interesting reports. For example, traffic stats, which shows the result of this deep packet inspection. So in here we can see what traffic I've had, or you can see the different types of traffic I've put through the network. You can go to users, you can see the different devices and how much traffic each device is used. It's quite an interesting breakdown, and this is caused by the deep packet inspection functionality. There's more information here, performance showing the CPU and memory load on all the individual devices, switch stats which shows the bandwidth on each switch port, speed test which is the internet connection speed. It's kind of interesting and it's quite nice having it all in one place. With a more traditional environment with separate devices, you'd have to log into each switch individually to get this sort of port level stats, if the switch even supported that. Whereas with UniFi, there's one interface that lets me view absolutely everything for the entire network, which is what I really like about it. There's more stuff you can do here. For example, you can get a map of your network. I've not actually set this up because I need to put a map of my own flat in, and I don't want to do that show it on video because it shows a full floor plan of my flat with my address and stuff printed on it. But you can put a map into here. You can draw all the walls on using by specifying what material the walls are made of, place your access point, and it shows quite a good looking map of how your signal is distributed, which is quite cool. Under devices here, we can see all the devices we have. So that's the 4 devices, the USG, the 2 switches, and the access point. And then going into these lets you configure them in a bit more detail. Next up, you've got clients. This shows all the clients connected to my network. And you can break this down into different things. You can separate it by wireless, wired, all that sort of stuff. And you can go into each device and you can see a bit more information about what the device is, you know, what stats it has, what sort of traffic it's passing. It's kind of cool. Now, Insights is where it gets really interesting. So this is all, again, more reports. So you can see here's switch stats. But you can also break it into all different reports. You can see neighboring access points, which will list other access points that are nearby to you. Clients that seen before, past connections, loads of sort of stuff in here you can go through. It's definitely worth playing about with. What I'll do is I'll chuck a link in the description and put it on your screen now to a demo of the UniFi controller software, because it's one thing me showing it, but Ubiquiti actually have a demo of this you can browse on your own machine without having the actual equipment, so it's worth taking a look at that and seeing what you can do. What we'll now do is we'll take a quick look at the settings. So to do that, we go down to settings here, and this will show the whole settings interface for the entire system. So this is the main screen, which is just basic settings for the entire environment. And if we go over left here to networks, this lists all the individual networks I've created. If we go into one, for example, my LAN one, you can see we say this is a corporate network, which just means it's not a guest essentially. It's using the LAN interface on the router. It's VLAN ID 100. Here's a subnet mask I'm wanting to use, the DHCP range I want to use, various things about lease time. You can set all this up in here. You save that, and that's that network now created on the router. This then creates a nice abstraction, so if I want to then set up a switch port that's on the LAN network, I just need to go to Devices, pick the switch I want, pick the port I want, and then down here I can then simply select what network it's on. So if I want to say put this switch port here onto the LAN network, I click the switch port, I change the port profile to LAN, and I save it, and that will now set all the VLAN settings on that switch port. So I don't have to worry about remembering what VLAN ID is the LAN network, what VLAN ID is the guest network. I just go into the switch and it gives me a nice simple name to describe that switch port, that port profile, which is really cool. You can also create custom port profiles. So this is enough if you want to have a single VLAN on a single port. But if you want to mess about with having separate tagged and untagged traffic on a certain port, you can do that. You go into switch ports here, you can create a new port profile, and you can go into more detail and say, right, the tagged network is LAN, and also the native network is LAN, which is the untagged network, and also I want to tag IoT on that. And you can just do that, which is really pretty cool. And then you can pick this network for your switch ports. So I do really like that abstraction. It makes it a lot easier to set up switch ports without having to remember what VLAN ID each thing's on, which is quite cool. Now, as for Wi-Fi, that's also configured through here. So you can go to wireless networks, and it lists all the wireless networks I've got set up. If I were to create a new wireless network, you go in here, you give it an SSID, set up security settings, and under advanced options, you can pick lots of other things, including the VLAN ID that you want to put the network on. This is a slight complaint because that nice abstraction of having different networks with certain simple names doesn't extend through to Wi-Fi. So at this point I do have to remember the VLAN ID, I can't just pick LAN from a drop-down. It's not the biggest thing ever because you're only going to set this up probably initially and not change it again, but it would have been nice if that abstraction of giving the networks names was carried across to Wi-Fi. But once you set all that up, you simply press save and that will propagate out to all your access points and all the access points will start broadcasting that network, which is really quite nice. On the left, you've also got routing and firewalls. This is where you set up static routes. Your firewall, where you can set up different rules on each interface. And then you can also set up port forwarding in here, which is quite cool. Now, one thing I have noticed in here is that the IPv6 functionality is listed as alpha. So that's a little bit annoying. So I'm guessing the IPv6 functionality for the whole system isn't really fully there yet.
Now my network isn't IPv6 enabled at the moment, so this isn't bothering me, and obviously they're going to fix it in the future because it's quite a critical thing. But if you're trying to do a lot of IPv6 stuff, you might want to be a little bit wary because this is obviously a bit alpha. On the left here, you've also got the IPS and IDS functionality. So this is intrusion prevention and intrusion detection. So you can enable that, you can pick different categories of traffic, and it will inspect that traffic, and if it detects any malicious activity, it will either detect the traffic and alert you, or it will block the traffic. Now, as it says up here, enabling this will disable hardware offload, and that will impact the throughput through the router, and it'll slow it down quite a bit. We'll take a look at a benchmark next, which will show the actual impact this has, but because of that, I do actually leave this functionality off. Next up, we've got deep packet inspection. This is just a simple enable or disable option, and this doesn't actually seem to impact the throughput. We'll take a look at the benchmark later. But enabling deep packet inspection gives you those traffic stats around what services have been used, how much streaming a device is doing, things like that. So this is quite cool to enable. There's also functionality here for things like guest control. I've not really looked into that too much yet, but overall setting it up the amount that I have, it's actually worked really well. One of my main concerns with going for a UniFi environment would be that there might be features that I'm not able to configure through the web interface, and then I'd be completely stuck. And doing the initial setup, I did find a couple of features that were missing from the web interface that I wanted to be able to configure. Namely, those were being able to set custom MTU values on my WAN interface, and then being able to add static entries into the DNS forwarder. The former is because my connection is a VDSL connection that I connect to over PPPoE. Normally this would mean that my WAN interface would have an MTU of 1492. This causes issues with certain websites. They're misconfigured and things don't load properly, and it can be a bit weird. I had a few issues when I previously had a pfSense router that ended up being related to this. There's two options to fix this. You can either set up MSS clamping, which is what it's called, which the UniFi system does actually support natively. There's just a box you can tick to switch that on. But the better option that my ISP supports is what's called baby jumbo frames. This means that I set the Ethernet interface my modem's connected to an MTU of 1508. I can then set my PPP interface to an MTU of 1500, which gives me a full 1500 MTU on my WAN interface, which completely eliminates the problem. Unfortunately, the UniFi interface does not let me set custom MTU values on the interfaces. Additionally, I also want to be able to add custom entries into the DNS forwarder. This is useful if I want split DNS, so I have my external DNS server resolving certain host names to certain IP addresses, but on my local network I might want those same host names to resolve to a different IP address, such as the machine's IP address on my local network. I also might just want to add an entry into the local DNS forwarder, just if I've got a single device that's only accessible when I'm at home. I don't want to go and add that to my main DNS server. And again, that unfortunately is not available through the UniFi interface. So that's pretty annoying, and I would love to see those features brought back into the UniFi controller. However, this doesn't mean that I'm completely unable to configure those settings. There's actually a way to override this. So first of all, if we go over here I am SSH into my USG. So you can just SSH into the USG using a username and password that's available through the controller. And now I'm inside the UniFi security gateway, which just runs EdgeOS, which is the same operating system that the Ubiquiti Edge routers run. And it's actually very similar to VyOS, which is what I used before. So through EdgeOS, I can configure a huge amount of functionality on this device. So for example, if I run the configure command, that takes me into configuration interface, and then you do things like set interface Ethernet ETH0, MTU, and that lets me set the MTU value on that interface. So that's where I can set those options that aren't available through the main interface. And you can do the exact same for things like the DNS forwarder. In fact, pretty much any setting under EdgeOS you can set through this interface. However, this doesn't fully work with UniFi, because while you can set the settings here and they will work, they won't persist. That's because UniFi is centrally managed, so while you'll be able to set the settings here, as soon as you reboot the USG or reprovision it, those settings get lost because it sets the full configuration based on what the controller has. However, hope's not lost. If we go over to the controller, which in this case is the CloudKey, you'll see there's this magical file called config.gateway.json. And if we open that up, you'll see some settings in here. So this is some custom settings that I've defined in this JSON file, in this JSON format. So here we can see at the top, we're setting the ETH2, which is the WAN interface, we're setting its MTU to 1508, and we're setting the PPP interface on that's MTU to 1500. And likewise down here, I've set up a static host mapping in the DNS forwarder to resolve testhost.cameragrade.me to a local IP address on my local network. So what you can do here is you can put all these custom settings that you set up in EdgeOS into this JSON file. All you need to do is save that file, go back over to your controller, find the device, in this case the USG, and then go to the force provision button. And when you force provision, the settings from that file will be applied to the USG, and that will set up the static host mapping as well as the MTU values that I've set up. So it's actually quite simple to do that. Of course, this is a little bit tricky to set up, so it would be much nicer if this was in the web interface, but there's a fairly easy way to write this file. So what you can do is if you go over to the actual USG itself, you set all the settings up in here like you would do on EdgeOS. So you set use all the configuration commands, the set commands, set all that up, and then save the configuration. Then all you need to do is run this command here, mcactrl-t dump cfg. And if we run that, that will dump out the configuration to a JSON format that you can then view on your screen. You can even export this to a file. What you can then do is go through this JSON file, find the sections that you want to manually keep inside the config.gateway.json file, and just copy those sections out of this file and place them into here. So it's not actually too bad. You do need to be a bit careful with this, because if you set up certain settings in here, you may then end up conflicting with what you've got set up in the main interface. So generally, the only settings you want to set in here are ones that are completely unavailable through the web interface, and that way you've got a reasonable separation there. So it's not the ideal solution, but it does mean that if there's any sort of advanced settings that you want to set up that aren't available through the main web interface, you do have at least some last-ditch attempt way to set it up. So it's at least got that, which is quite nice. So now let's look at some performance tests. So the first test I tried out was WAN to LAN routing, where I put one laptop on the WAN side of the router, one on the LAN side, and ran iPerf3 between them. I ran 3 different main tests, one with large TCP packets, one with small TCP packets, and one with UDP using iPerf default packet sizes. For each of them, I then ran a download test, an upload test, and then for control, I looked at the layer 2 speed, which is the speed of just 2 laptops on the exact same switch on the local network, so there's no router involved, to use that as a control figure. And as we can see, the performance is great. So we get full gigabit speeds for large TCP packets in UDP. There was very little performance difference between going from the full raw layer 2 speed, which is the maximum you'll ever get, down to actually getting the speeds through the router. There's basically no difference, it's all within margin of error. Now with really small TCP packets, obviously the throughput's a lot lower, but as you can see, the throughput through the router isn't that much lower than the actual layer 2 speed, so that performance is also fine. The next test we'll take a look at is inter-VLAN routing. So this is very similar to what we had before. However, instead of having one laptop on the WAN side and one laptop on the LAN side, both laptops were on the LAN side of the network, but on separate VLANs, and the router was routing between the 2 VLANs. And as we can see, the performance is again exactly what you'd expect. For large TCP packets and UDP, it gets effectively wire speed. There's very little difference between the inter-VLAN speed and the devices running on the same VLAN. And again, for small TCP packets, the throughput is exactly the same versus whether it's going through the router or just going through a switch. So the actual routing performance seems really good. Now the next test we'll take a look at is what happens when we enable deep packet inspection or the intrusion detection or intrusion prevention systems. So here's a test I did. So I tested both WAN to LAN routing and inter-VLAN routing and enabled each of those features one by one. So as we can see, with none of those features enabled, we still get full wire speed. And when we enable deep packet inspection, we again pretty much get wire speed. We're maybe losing a couple of megabit, but that's pretty much margin of error. So enabling deep packet inspection does not impact the performance, which is good because I was seeing mixed things online. However, when you enable intrusion prevention or intrusion detection, then it starts to impact the performance quite significantly. I did 2 tests for this. The first one just had the default categories enabled, and for the second one I enabled all the categories within the system, just to see how that would impact the performance. And we can see that it does quite significantly impact it, bringing the throughput way down. For WAN to LAN routing, it pretty much caps at about 400 megabits or just slightly lower, which to be honest is better than what Ubiquiti said because their documentation says it caps at about 250 megabits. So it is actually a lot better than what Ubiquiti say, but it does cap the performance quite significantly. The more annoying thing that I saw was that it also seems to cap the inter-VLAN performance. If it was only WAN to LAN, that wouldn't bother me because my internet connection is currently 80 meg down 20 up, and when I upgrade it I'll probably go into something maybe 330 down 50 up. So with this performance here it would be fine. 391, 389, that's still beyond the internet connection I would be getting, so it wouldn't bother me. However, the system would also impact the inter-VLAN routing performance, which is what I actually really want, and I need gigabit speeds for that. So you can see here that it caps the inter-VLAN speed at 491 megabits a second if you've got only the default categories enabled, and if you enable all the categories, it caps the inter-VLAN speed at 439 megabits a second, which is quite a significant decrease. Again, it is a lot better than Ubiquiti say, so that's a good thing. However, it's really worth bearing in mind, and it's definitely a shame that it also impacts inter-VLAN routing and not just WAN to LAN routing. I'd love if I had the option to say, right, I want intrusion detection or I want intrusion prevention, but I only want it for internet traffic and not for any local network traffic, because that would solve this problem. And if I was able to do that, I would definitely leave it enabled. But at the moment, because it caps my local network speed as well, I've had to leave that feature switched off, unfortunately. But it's definitely good to see that the deep packet inspection does not impact the performance, so I'm happy to leave that enabled. So the next test I did was Wi-Fi performance, which is definitely going to be really interesting to see on that access point. And for this, I just used my MacBook Pro laptop as a wireless client and set the access point up in one corner of my flat and then tested the speed at various distances from the AP. And we can see the performance is actually really good. So the first test just had the laptop sitting in the same room as the access point, and I got well over 400 megabits a second down and up to and from the laptop, which was absolutely brilliant, so that's really good performance. Next, I moved the laptop through to the next room through a single stud partition wall, and it was about 4 meters away. And the performance dropped slightly, but not too bad. I'm still getting well beyond 400 megabits a second, which is really good. So for the final test, I put the laptop at the complete opposite end of the flat from the access point and shut all the doors in between. So this was about 12 meters away with lots of obstructions in the way. And even then, the performance wasn't too bad. I got well over 200 megabits a second download to the laptop, and still could upload at 140 megabits a second, so that was pretty good. The next test I did was on 2.4 gigahertz, and the performance obviously is not nearly anywhere close to the 5 gigahertz, but it was still relatively acceptable. I was getting about 80 down, 60 odd up when I was reasonably close to the access point. However, when I moved about 12 meters away, it actually dropped quite significantly to only about 27.5 megabits a second down, but still reasonably fast upload. So as you can see here, that while the 5 GHz performance is brilliant on this device, the 2.4 GHz isn't that great. Now this doesn't bother me too much because all the devices I care about the performance on that I own are 5 GHz capable. However, it's worth bearing that in mind. The NanoHD only has a 300 megabit a second 2.4 GHz radio, so if you wanted 2.4 GHz performance, you're probably better going to something else such as the USG Pro, which has a 450 megabit a second 2.4 GHz radio. So with the NanoHD, you're definitely sacrificing 2.4 GHz performance a bit, but the 5 GHz performance is so good, it's definitely worth looking at. It's also worth bearing in mind that in my environment, I'd never have this bottom option where I have it about 12 meters away, because my access point is normally located centrally in my flat. So pretty much anywhere I go, I'm within the middle band of 4 meters away or so through a single stud wall. So I pretty much can reliably get about 400 megabits a second at least in every room I'm in the flat. So the performance is absolutely brilliant for my environment, and I can easily serve it from a single NanoHD access point. So the next test we'll take a look at is the speed differences you get between different types of devices. So as I mentioned before, the NanoHD is a 4x4 multi-user MIMO access point. This means that it's rated for 1733 megabits a second. However, that's only for devices that would support 4x4 MIMO, which basically no devices support. The less streams your device supports, the lower the throughput you'll get, and this is what you can see here. So these tests again were just done using iPerf3 from about 3 meters away from the access point, and I tried with 3 different devices. My MacBook Pro, which supports 3x3 MIMO, my previous ThinkPad T440S, which supports 2x2 MIMO, and my Honor 10 smartphone, which only supports 1x1 single stream AC Wi-Fi. And you can see the performance impact that it has when you start losing streams from the device. So you can see the performance here with the MacBook Pro. I'm getting really good speeds well in excess of 300 megabits a second. When I move back down to the ThinkPad, it's a bit slower. I'm looking at closer to just below 300 to about 250. And then we go down to the phone, which is only a single stream. We're looking at well below 150 megabits a second. So it's just worth bearing in mind that if you're going for an access point like this, you can get the fastest access point in the world, but if your device doesn't support 2x2 MIMO or 3x3 MIMO, your performance is going to be severely impacted. Now, most good laptops will support at least 2x2 MIMO, but I looked online and a lot of the cheap, few hundred quid Acers and those sort of laptops, they still only support single stream Wi-Fi, which is a bit rubbish, so it's worth bearing that in mind. But the Wi-Fi performance on this is absolutely brilliant, especially using a device like the MacBook Pro with a really good built-in Wi-Fi chipset. So I'm really happy with the performance of the NanoHD. So it's now been a few weeks since I installed the equipment, and it's been working absolutely brilliantly, and I absolutely love this hardware. So you can see it all installed here. It's exactly the same as it was before, although there is one change, and that is up here. So as I mentioned previously, I'm running out of switch ports here, and I need a pair of extra ports to install 2 of the cameras I'll be fitting. So what I've added is this SFP to RJ45 copper module. This is a Ubiquiti module, and it's not actually that expensive. So I've added that in there, and it gives me an extra copper port using one of the SFP ports. And it seems to work really well, so those are definitely a very good option if you've got one of these UniFi switches and you want to add in a couple of extra copper ports, and you've got some SFP ports you aren't using, because you just chuck that in, completely plug and play, and that gives me an extra copper port, freeing up 2 regular switch ports to connect to those cameras. So that works really well. So yeah, my only real complaint about the hardware here that you can possibly hear in the background is the noise of the security gateway's fans. They are definitely quite loud. Now of course it's very hard to judge the noise of fans, but essentially this is currently located in my hall cupboard. So if I have it in the rack with the door in the rack shut and then shut the cupboard door, the noise isn't a big issue. I can't hear it in any of the living rooms of the flat. So I can't hear it in my living room, the bedroom, the office, you can't hear it in there at all. However, if I'm standing outside the cupboard door, I can then hear it, and this has quite a heavy fire door on it. So it will make its way, the noise will go through a door potentially, but it's not too bad apart from that. So essentially you wouldn't want this device in a room that you're going to be living in, and you probably wouldn't want it in a room such like a cupboard off of a room, so you wouldn't want it in like a bedroom cupboard for example, because the noise would still be audible. But as long as you're keeping it reasonably far away from where you're living, the noise is okay. Of course you could potentially get sound dampened racks, and those fans do look quite replaceable, so we might look at that in the future. So the noise definitely doesn't bother me too much, but it's worth bearing in mind if you're thinking about fitting this. Just make sure you can put it away from somewhere that you're going to be living, because the noise is quite noticeable. So yeah, I'm actually very happy with this setup. It works really well, and I can't wait to try out more stuff with it. And also stand by for the next video where we're going to take a look at the cameras and the whole UniFi Protect system. And then after that, I've potentially got a couple of interesting home automation videos coming up, so stand by for those as well. But yeah, thank you very much for watching.